All right, so the application is set up, seems to be working. So now what's next? Well, as we touched on a little bit before, the next part is going to be testing. And let's talk a little bit about testing. The main reasons why anyone writes tests, especially in the backend, is to ensure that the application works the way it should. And I actually really like this approach because the main reason I like, or in particular, my first assumptions about any problem are almost always flawed in some way. And so tests help me hone my mental models early on and then allow me to juggle fewer variables in my head at a given time. So like offloading some of that mental strain to automated testing is definitely a nice approach. Especially when I'm just starting on a project, tests highlight my initial misconceptions quickly and then give me a familiar platform for introspection. So I really like testing in general. And on top of that, whenever I want to refactor my application, I can just run my tests every time I change the code. And if the tests are still passing, I can be confident that nothing is breaking as the result of my changes. And that lets you refactor with confidence. And that's maybe the most important part about testing. And so setting up a nice testing framework is a really important part of building a production grade system. And so the first thing when you think about with testing is, what is your tooling? When it comes to tooling, for us at least, we're going to be using two modern libraries that have become pretty popular in recent years, Jest and Supertest. Now, Jest is a JavaScript testing framework developed by Facebook. And it's extremely powerful and works pretty easily with not a lot of configuration, and will act as our test runner, assertion library, and just general testing framework. The other one we mentioned, which is Supertest, is a library to make HTTP requests to our application within our tests. It simplifies sending those HTTP requests as if the application were running, so that we don't have to worry about that at all. And getting started with them is actually pretty simple. But we're going to handle this a couple ways. The first thing is that, even though this might not be the best way to do it, I actually prefer to have Jest installed globally so that I can run it from my command line whenever I want to. And so the first thing is, if you don't have Jest installed globally, you can do that by running npm install jest-g. And G stands for global. And so if you npm install jest global, I think I already have it installed here, so it shouldn't be a problem. But once Jest is installed globally, then we want to install some dev dependencies locally into our application for Jest and Supertest. And we'll do that with npm install --save-dev Jest Supertest. Notice we're only installing these as dev requirements. And by writing this save dev here, we're essentially saying that these dependencies are only for when we're developing the application, so that they're not included in the production bundle. So once we have those set up, we can actually add a test script to our package.json file. So head into your package.json file here. And oh, by the way, notice this. Dev dependencies, Jest Supertest, all these other cool dependencies there as well. This looks pretty good. And here we're going to replace this test script with this. We're just going to say test jest-i. And the I is just a flag to run tests serially. But you don't have to worry about it too much. We can talk more about that later. And save that. And then, and again, this script is what we're going to use to actually run our tests with Jest. But that's really all we need to do to get started writing some tests. So to get this testing system integrated into our application, we're going to do a slight refactor to our server file. And in doing so, we're going to separate the server right here from the application itself. And what I mean by that is this app starts up here. The startup code that actually starts the app is right here when we tell, hey, server, I want you to listen on the port we've configured. That all happens here. But the application itself is really all of this set up here, this little pipeline that we created. And right now, since we have all of our application code living in one server file, if we actually ran our tests, it would load up this file and it would try to start our server every time we ran our tests, which is not actually what we want. Instead, we're going to separate this out and then import it into our server so we can test just the application itself. To do that, we're going to create two new files. We're going to touch an app.js file and an app.test.js file, like that. Now this is cool. Look at that nice little icon. It's got that cool little chemistry flask thing going on. I appreciate that. By the way, this general syntax here is how we'll structure our testing files. We create an identical file with the test suffix in between the actual suffix and the name of the file. Jest will know to look for all files that end with a .test.js, so this helps keep things organized. So let's actually go ahead, and I'm going to copy all this right here from our server, and I'm going to delete it. Oh no, it's gone. And then I'm going to go into my app.js file, and I'm going to paste it in here. Ta-da! Now notice, by the way, we no longer need the port here, so we can actually just take that out and drop it back into our server. Cool, but our server needs the app. Where are we getting our app from? Well, easy enough. We just take this app that we created and we export it. Module exports equals app. And then in our server, we just import the app, just like any other module. Ta-da! Yeah, not bad, right? Functionally the same, but we've separated the startup code, which is all here, from the application code, which is all here. Let's actually start this application and make sure it still works. Maybe I broke something. Looks like it didn't. I feel pretty good about that. Great. We've now isolated the application from the startup code so we can test the application itself. To do that, we're going to write a simple test in this app.test.js file that will ensure that our app has a simple routing functionality, just to get our feet wet. We'll say const request equals require Supertest, which is such a cool name. Then we'll import the app, and we'll also import the DB. Then we're going to write our first test. Now the syntax might look a little weird to you, and that's totally okay. I'm just letting you know that it's going to look a little weird. Here's how you do it. We're going to write describe test application. We're going to give it a callback function. And inside this block, we're going to say test. No, just test. Oh boy. VS Code, I need you to chill. Test. No, thank you. And we're going to say not found for site 404. Say async callback function, and we will say const res equals await request app dot get no or wrong path, wrong endpoint. There we go. And then we'll say expect res.status code to equal 404. Then we'll say after all, run an async function that awaits db.end. Ta-da! Now, you might be thinking, what is going on here? And that's totally fine. If you've never seen this general testing system before, I recommend reading the Jest docs. They'll explain a little bit more about this. But just to touch on this really quickly, this describe function is a global provided to us by Jest that is used for grouping together related tests. This test function here actually runs the test. Both the describe and the test function take a callback as their second argument, where we add all the actual testing code. This one is async because we're making an actual request to our application using the Supertest library. And so we pass our test to Supertest, and then call whatever HTTP method on it with the path that we're making the request to. We'll see how to send data in post requests and modify HTTP headers and other stuff like that later on. And then finally, we have this cool expect thing here, which tests a value using a set of matcher functions that are provided to us by Jest. So here we're just leveraging the toEqual matcher function, though there are a lot more. I tend to mostly use things that just check for equality by asserting one thing is equal to another, and because that's really meets most of my testing needs. And then at the end, we have this after all hook, global hook, that ensures we disconnect from our testing database as soon as our tests have finished running. Now, if we ever need like more complex matching functions, you can head over to Jest and they have a section on using matchers and how to do all this expect stuff that we just showed, and then all the different things you can expect. You can expect a bunch of stuff. To be, to equal, to have been called. There's all different kinds of things here that are a little outside the scope of this. We'll kind of just like talk about them as we introduce them. So, with that ready and to go, let's go ahead and stop our server, and let's run our first test. We will say npm test and hit enter. And let's see what happens. Ooh, ta-da! Amazing. Works as expected. We get a nice message about tests run and the results. So really all that happened here is it said, cool, console.log. Oh, it logged my setup. So I still get all those console.logs. What happens when my application imports config. So this is standard out. And then we get which test passed with app.test.js, how many passed, how long it took, and then at the end, it connects and all that good stuff. Seems to have worked, right? Cool. Now, what does it look like when a test fails? Well, let's change this from 404 to 200 and see. Run npm test again. And, okay, we have a failing test, and it tells us where it failed, what was expected, what was received. And that's actually really nice. I like that so much. Now, we have a test that works, but it's usually not best practice to write code first and then write a test that shows that it works. There's a different approach, which is the test-driven development approach, or TDD, that involves writing the test to describe how we want the feature to work, and then writing just enough code to get that test to pass. Then, we can refactor our working code until it's closer to what we want. And this strategy is sometimes called red-green refactor. So, red, here, since we write a test that fails. Green is we write just enough code to get the test passing, and refactor for the cleanup process where we improve the code we already wrote. So let's set this back to a 404, so it's where it was before, and let's try a simple example of red-green refactor. We'll add a health check route to our app to verify that it can receive an HTTP request and return a 200 response. And we'll do so with our TDD methodology. So let's add a new test case here. Let's call this test health check route returns valid response. And then we'll give it a callback function. And inside there, we'll say const res equals await request app.get / just to the / endpoint. And then we will expect the res.status code to equal 200. Let's just stop there for a second. Let's try it out. Let's run our tests again. And, okay. So one test failed, one test passing. That's what we expect, right? So health check route return to valid response is failing because that route doesn't exist. And to get it passing, all we need to do is go into our app and we'll say app.get / this will be our health check route, and it'll run a recResNext route handler function that does res.json, and we'll just send back an empty object. Just enough to get this test passing. Let's see if it passes. Ah, magical. Cool. Okay, now let's update this test a little bit. Let's add another case to it. We'll say expect res.body to equal, let's say ping pong, which is like something that people often use in health check routes. And so we run our tests again, and we see they are failing. Sad day. No ping pong. Expected object ping pong got object empty. So then we go back in here, and we will say ping pong. Save it, run it again, and perfect. So again, the failing test is the red we're talking about. It lets us know, hey, actually, that status code here was supposed to be a 200 and it was a 404. And then we went in and we changed, we added the endpoint, and then it was passing, and then it was green. That's great. The green is just like just enough code to get our test to pass. And then we went back in and we added another test case here, and then we updated the health check route again to make this test pass. And so this is kind of going through red, green, and now when we have something in a good place, we can refactor this a little bit. And to do that, we'll head back into the app and we'll say, hey, by the way, I actually like to be pretty explicit about this. and give it the actual status code that it's sending back. So we'll say res.status200 and the JSON, and then we'll run our tests again to make sure they're still passing after we've changed our code. And that's the refactor part. So the red is make sure you write a test that's failing. The green is write just enough code to get it passing. And then the refactor is refactor it and make sure the tests are still passing after the refactor is done. And that is one approach to the test-driven development methodology. It's really just standard testing at its core. And that's pretty much it. We've run our first test and it works and we're happy. And so the next question is like, what do we test? Well, honestly, we could test everything. And my preferred method is just to test the core functionality of my app. So all the models, the routes, the middleware, and also even write unit tests for utils if they're important. And let's actually go ahead and do that. Well, let's write some simple tests for some like other let's go with the config. Let's start with the config module, and then let's test some of the JSON Web Token utils, because those are pretty important to our application. But now that we have our testing framework set up, let's commit our code. Git status, great. Git add, git commit, working, testing, framework, ready to go. And we are ready for the next part.